Testing, testing. Okay, let me see if the audio is being recorded. Okay, fantastic. Alright, so previously in the last video, what we did was to kind of introduce the syllabus for A Math, and we have also went through somewhat about completing the square and using it to prove inequalities, so on and so forth. So for today, what we will be doing is we'll move on to the second topic, which will be interested in the study of quadratic equations themselves. In other words, instead of finding x, we're interested in the math problem itself. And we will also be studying the idea of quadratic inequalities, meaning to say that we will no longer be doing simple inequalities where we prove O positive, O negative. We're going to look for specific results. So that will be the idea over here. Right, so please make sure you have your notes with you, because I will be going faster today now that we have, already went through the first video, right? There's no need for me to go slowly anymore. So let's begin. The first thing I want to talk about is for quadratic equations. So far, everything we have been dealing has always been pretty straightforward, right? We have been working with quadratics in the form of ax squared plus bx plus c equals to 0, where a, b, and c are numbers, and then afterwards x is the algebra that you're interested in. So we can actually have quadratics combined with a linear. In other words, we do simultaneous equations, except one person is linear, the other person is quadratic. So when that happens, fortunately, your strategies will still be the same. You can either do elimination or you can do substitution. So in this example over here, we see that they have given us two equations. The first one is unusual because there's a square on the x, there's a square on the right, on the y, right? We have two squared terms, two squared algebras. And as for the second piece of information, this is a lot more straightforward. 2x plus y equals to 1, which is linear. Therefore, what we will do is we shall simply start with the linear person, right? And then make y the subject. Once this is done, we will then be able to do substitution. Right, for those of you who have already been in my classes, you will remember me telling you all the time that substitution is preferable. It is more brain dead, you don't have to think so hard compared to elimination. So we're going to do substitution into the quadratic. You will notice that we had y squared, and now that we do a 1-for-1 replacement of y with 1 minus 2x, y squared will change into 1 minus 2x squared. From there, you can simply open everything up and go on to solve the quadratic equation. This will give you a total of two different results, right? Two different results, first and second. And in this case, the two results are x equals to 0 and x equals to -1. Once you have these two results, you will need to substitute them both back into the original substitution you used. Originally, we replaced y with 1 minus 2x. And now we have successfully found x, which means that we can simply plug it back in to find y, right? So we have x equals to 0 or x equals to -1. And then equation number 2 tells us that y equals to 1 minus 2x, which will be equal to 1 minus 2 times 0, in other words 1, or will be equal to 1 minus 2 times -1, which will be equal to 3. So we have 1 and 3 respectively. When you present your answers, make sure to combine the relevant numbers together. So for example, over here 0 on x gave us 1 on y. So these two need to be put together over here. Similarly, over there we have -1 on x giving us 3 on y. So this one will also be presented together like so. Alright? Honestly, a lot of this comes down to the same algebraic techniques that you have learned way earlier, 1 year ago. So I don't have too much to say. We will go through some more exercises later. Right, now, the next thing I want to move on to is we will leave the realm of finding the value of all these random mysterious algebras. Instead, we shall move on to find the story of when a math problem even has an answer in the first place. So we will learn about this thing known as quadratic discriminant. What we need to first understand is that inside your quadratic equation, right, this is the math problem. Inside the quadratic equation, we actually have a formula that always tells us the answer, right? Always tells us the answer. And over here, we notice that the most important part is actually b squared minus 4ac. Because if it is negative, what we're going to get is we're going to get the square root of a negative number. And this is going to give us an error in the calculator. For those of you who are in the know, the square root of -1 is actually imaginary, right? Which means that you will end up with a complex answer. Therefore, what we say is that if b squared minus 4ac is negative, we will have no real number answer. We will have no real roots. In general, this important portion, b squared minus 4ac, is known as the quadratic discriminant. And then sometimes we use the symbols delta or capital D. In your actual exams, it will probably make more sense to simply write discriminant. Right? Make sure to spell the word correctly. So, aside from all this talk, the next thing will then be how do we use this discriminant? The idea is somewhat straightforward. The first thing we need to recognize is, just as I said earlier, if the discriminant is negative, that means that once we use the undefeatable quadratic formula, we're going to get the square root of a negative number, which is undefined. Therefore, if I have negative discriminant, we say that there are no real roots, no real solution. This also means that you have no x-intercepts, and as a result, we will not even cut the x-axis, right? The graph will be floating on top, floating below, either one. And because it's always floating above, floating below, that also means, naturally, that the graph will either be always positive or always negative. You will recall these phrases from our previous video, where we used completing the square to show that someone is always positive or negative. So now we have a second strategy. Instead of completing the square, which is difficult and ugly, we can actually just use the discriminant and then check from there. Now, there are two other situations. One of them is where the discriminant is equal to 0. If it is equal to 0, what this means is that we have one distinct real root. In other words, only one unique solution. So as an example, we can trivially consider the example of x squared equals to 0. X squared equals to 0 will mean we have 1 x squared plus 0x plus 0 equal to 0. So over here, a equals to 1, b equal to 0, c equal to 0. From here, then the discriminant of the quadratic will simply be b squared minus 4ac, which will be 0 minus 4 times 1 times 0, which will be 0 minus 0, in other words 0. So the discriminant is equal to 0, and that means we have one solution. And this makes sense because let's go back to the original math problem. X squared equals to 0. That just means that x equals to plus minus square root 0, which is equal to plus minus 0, which is equal to 0. So this is only one solution, and therefore it agrees with what we have written over here. Alright, last but not least, and this is the easiest scenario, if your discriminant is positive, then that means that the square root of the discriminant will simply turn into the square root of a positive number. And if it is positive, then obviously we're going to have plus minus in front because we can actually get an answer. And because there's plus minus, that means we have two different ways that we can go. We can go positive or negative. And this means we have two different answers. One last important thing to take note for the discriminant is that it actually works for anything that has a square. In other words, we don't need to have ax squared plus bx plus c only. You don't even need x. You can have y. You can have both x and y. You can have any algebra you desire, as long as it is a square. We will then be able to use the discriminant to find the number of solutions. So the discriminant will work as long as I have something square, and it will tell you the number of solutions, which will also tell you the number of intersections on the graph. If you remember what you learned last year, we know that one way of solving simultaneous equations is to find the number of intersections, correct? So in the case of a quadratic, you might get, for example, something like this. This will be two intersections, two solutions, which means the discriminant is greater than 0. If instead you have a situation, for example, like that, right, where the line and the curve don't touch each other, then that means that there are no intersections, therefore no solutions to the simultaneous. Therefore, the discriminant has no, or rather will be lesser than 0, to show that there is no solution. Right? So this works regardless of whether you're dealing with a quadratic in y square, or if you are dealing with a circle. Right? Now let's move on. Be reminded that you can always pause the video and take a look yourself, but for me, I would not like to spend so much time. Now the last thing we need to cover for today is the idea of a quadratic inequality. So for quadratic inequalities, what we will be doing is we will deliberately draw the graph of the quadratic. Typically, what this means is that when you are given a math problem, for example, 2x squared minus 21x plus 40 less than 0, when you are given a math problem like that, and the question doesn't ask you to prove, the question asks you to find x, then what we will do is step 1, we will factorize. Step 2, we will draw the graph. It doesn't have to be a perfect drawing, right? You can just kind of make it a very rough sketch. We know that this is going to be a U shape because the coefficient of x squared is positive. And from the factorization in step 1, we can find the x-intercepts immediately. Right? So from here, then we will simply ask ourselves, do I want to be greater than 0 on top, or do I want to be lesser than 0 below? In this case, the question says, lesser than 0, right? Look on the left, lesser than 0. So if it's lesser than 0, I'm going to be below, which means that I'm going to be in this brown colored zigzag portion, which is in between 5 over 2 and 8. In between. In other words, x is greater than 5 over 2, but at the same time x is lesser than 8. And this informs us of the answer. So this graph drawing technique will be what we will use, right? Similar thing for part B. Part B gives us a different math problem. They tell us that you have this 2x squared plus 22x minus 84 greater than or equal to 0. So again, step 1, factorize. Step 2, we will draw the graph. This is also a U shape, and it cuts, in this case, at negative 14 and positive 3. We have positive on top, negative below. The question wants us to find greater than or equal to 0, which means that we're looking on top over here and over there. So we will be to the left of negative 14, to the right of positive 3. And to the left means lesser than, to the right means greater than, which means that my answer will simply be x being lesser than negative 14 or x being greater than 3. Of course, in this case, you notice the inequality is not strict, right? It's lesser than or equal to, so don't forget to add the extra line underneath. At this point in time, one other thing I want to point out is that we will use the English word or, we will not use and. And implies both things at the same time, which doesn't make sense. If I'm equal to 3, I cannot be less than 14. I cannot be less than negative 14, sorry. And similarly, if I am less than negative 14, there's no way I'm going to be greater than 3. You can simply imagine your number line, right? Let's say this is 0, this is negative 14, and this is 3. If I am greater than or equal to 3, that will mean that I am all the way on the right over here. And this doesn't make sense because I also want to be less than negative 14, which is all the way on the left. In other words, having both at the same time is impossible. And therefore, instead of using the word and, we have to use the word or instead. Right? I will leave the third problem over here as an exercise, and we will talk a little bit about drawing of the answers on the number line, which is very similar to what I just did moments ago. What we will do is that on your number line, we will have a horizontal line that denotes the real numbers, right? I believe we covered this in the previous video, real numbers. So over here, we will have to write down the numbers we're interested in. In this case, we are interested in, this is part A. We're interested in 5 over 2, and we're interested in 8. Now x, based on our answer from earlier, is in between 5 over 2 and 8, which means that I will simply draw a diagram like this. As a reminder, when you are on the number line, a dot represents a specific number. So for example, if I draw a diagram like this, what this would mean is that x is equal to 2 and y is equal to 6. The problem is we are not dealing with individual numbers right now, correct? Right now we are dealing with a range of values, and therefore you can imagine it as many dots put together. And when you have an infinite number of dots, surprise, it actually forms a straight line. Therefore, our diagrams for these inequalities, for these range of values, these diagrams will actually end up being lines instead of dots. In this case, I will draw a line from 5 over 2 to 8. And on top of the endpoints, on top of the start, 5 over 2, and on top of the end, which is 8. During these two critical places, then I will put the dot. In this case, the dot is hollow, right? It is a ring. And the reason it is hollow is because I cannot be equal to 5 over 2. I cannot be equal to 8. It is a strict inequality. That means that if I'm not equal, I cannot use a normal dot. Which means I cannot use a line either, because a line is made up of dots. Therefore, I'm going to use this open hollow dot instead, drawing a small little circle over there to tell them, okay, we will stop here, but we will not include this specific position. Consequently, if we do want to include something, such as for the answer in part B, right? Part B, this one over here. For part B, you notice that it is no longer a strict inequality, right? We have negative 14, we have positive 3, and we can include them as well as the numbers that are to the left and to the right respectively. Hence, we will not just use a hollow dot and draw the lines. We will actually use a legitimate full dot, a shaded dot, to tell them that, okay, I'm ending at negative 14, but I include negative 14 as well. Right? So X will take this range. It will no longer be a single line, it will actually be split into two parts. Because if you remember what we discussed earlier, we cannot use the English word and. It's impossible to be in two different places at the same time. Let me say that again. It's impossible to be in two different places at the same time. Two different places. And that's why your diagram, of course, should be split into two pieces. Alright, remember to pause the video or to slow the video down on whichever if you have any issues. We're almost done with this topic. The last thing I want to do is we have a few exercises right at the very end, and I would like to go through some of these exercises. So let's take a look at a few selected problems, and then we will call it a day. Right, so let's start with question 3. Question 3 tells us that we have to find the unknowns A and B by doing simultaneous equations. So in this case, we don't really have a lot to say. It is not a very sophisticated math problem. For 3a, they tell us that a minus b square, which is equal to 1. But this has a square, so you don't want to start with this guy. Let's just call him equation 1 and move on. Let's take a look at the second person instead. A minus 2b minus 3 equal to 0. This is very nice because it implies that a equals to 2b plus 3. From here, we will collect this thing and call it equation 2. Then we can do substitution. Again, as I always say in class, substitution is a little more brain dead than elimination. I wholly recommend it. So we will have a, which is 2b plus 3 minus b square equal to 1. Right? So a has now turned into this guy. So now we have a minus b equals to 1. From here, this obviously implies that b plus 3 square is equal to 1. Right, once you have b plus 3 square is equal to 1, then from here, it will be simple enough to undo the square by performing a square root. Don't forget to add the plus minus. And from here, b will naturally be equal to 4, or will naturally be equal to negative 4 or negative 2. Once you have found the b values, we will use the substitution from earlier, which is number 2, and say that a is equal to 2b plus 3, which will therefore give me negative 5, or it can be equal to 2b plus 3. And this over here will be equal to negative 1. And we will conclude that the answer will be a equal to negative 5, b equal to negative 4, or a equal to negative 1, while b is equal to negative 2. So you will have two pairs of answers, just as we said earlier. For 3b, question 3b, more or less we have the same scenario. So I will simply write down the answer for you, and you can consider it by yourself. Try and do it by yourself first as an exercise, then afterwards you can compare your steps with mine. Once again, you do not want to start with the quadratic. Start with the linear person instead. right? So we'll do a one-for-one replacement like so. There afterwards, we will simplify everything. Once you work through all the simplification, you should get this result. From here, what I'm going to do is I will make the numbers look a little nicer by dividing by 8/9. This will give you the dramatically nicer looking quadratic 5b squared plus 11b minus 16 equal to 0. And from here, it will be a simple enough affair to factorize. The factorization implies then that b equals to negative 16/5 or 1. Then just like in question 3a, we will be using our first substitution, and then we should get two different values of a based on the two different values of b. I'm trying to do all this mentally, so you might see me freeze for a few seconds while I think about it. Right? So we will conclude that a equals to negative 9/5, comma, b equals to negative 16/5. Alternatively, we can also have a equals to 1, b equals to 1. Again, two pairs of answers. It will not always be two pairs of answers. Sometimes it could be one, sometimes it could be none, right? Because of what we learned earlier about the quadratic discriminant. Right, so the next problem, question 4, tells us that we have something known as a hyperbola. Now, most of my students who are watching this, you're going to be 14 years old, 15 years old, and you, chances are, have not heard of all of this yet. It's fine. So, all we need to know is that this weird thing, this hyperbola, happens to have x squared, happens to have y squared, right? So we can still use the same tricks as always. I can use simultaneous equations, or if the question wants me to prove how many intersections, I can use the discriminant. Right, so the question says that we have this hyperbola, which will be this guy, right? For some reason it's split into two pieces, but you don't need to worry too much about it. And there is a straight line that's given to us. This straight line over here will cut at the position P and at the position Q. And they want us to find the distance between P and Q and show that it's exactly square root 80. So in order for you to find the distance, you'll need to find the positions first, right? For example, we know that the distance between 1 cm and 4 cm is 3 cm. Why do we know that? Because we can take 4 minus 1. But that means we need the 4, we need the 1 in the first place. Where do I start? Where do I end? Therefore, in order to find the position P and the position Q, we will be doing even more simultaneous equations. Right? We have x plus y. Let me write the question number. Question 4. We have x plus 2y equal to 2. Clearly, this implies x equals to 2 minus 2y. We'll call this equation 1. Then afterwards, we will substitute 1 into the hyperbola. The hyperbola is x squared minus 8y squared. So we will have x squared minus 8y squared. And afterwards, plus 8 equal to 0. From here, you will get negative 4y squared minus 8y plus 12 equal to 0. Very naturally, we can then divide by negative 4. Right? And this will give us a dramatically easier math problem. We will factorize this, and it tells us that y equals to 1 or 3. Then we will use the first substitution and get x equals to 0 or 8 based on the numbers we found for y. Therefore, we have p to be 0, 1 and q to be 8, negative 3. If you remember the symbols introduced in the previous lesson, then of course, do take note that we will not use the equal sign, we will use a colon when we are describing coordinates. Because if you write P equals to 0, 1, right? I might be a little confused. Is P a vector? Is P a 1 by 2 matrix? Is P an ordered tuple? So in order to eliminate that kind of confusion, we will not use the equal sign, which carries this very mathematical meaning of equality. Instead, we will simply just use the colon as a short form for the English word is. So position P is 0, 1, position Q is 8, 3. From here, if you want to find the distance PQ, it will simply be a matter of using Pythagoras theorem. Right, so you can use Pythagoras theorem over here, which you have 8 minus 0 square plus negative 3 minus 1 square, add a square root like this, and then this will give you square root of 80, which is what we wanted to show, QED. As a reminder for my students, you will not be allowed to QED your way through the exam, so please write the word shown or proven instead, because apparently Singaporean students are not swag enough to use the phrase QED. So you can't use the square symbol as a short form either. Right, now, the next problem is question 5. Question 5 asks how many distinct real roots do the following equations have? Now, distinct just means different in behavior, in appearance, so on and so forth. And real roots in this context simply means the solution to the math problem. The solution to the math problem is the real root to the math problem. These are synonyms. At least these are synonyms at your current level. Therefore, for question 5, this is simply asking for the number of solutions, which is the perfect time for us to use the discriminant. So in this case, the discriminant will be b squared minus 4ac. Very clearly, this thing will be negative 64, which is lesser than 0, implying that we have 0 distinct real roots. Right, as a reminder, if you have ax squared plus bx plus c equal to 0, the quadratic equation, your discriminant will be b squared minus 4ac. In other words, the portion that receives the square root inside the quadratic formula. Right? So for part B and part C, it will all be the same. Do keep in mind, however, that because the discriminant comes from the quadratic equation, you will have to change it into quadratic equation form first. So for those of you who saw the previous video that we did already, you will recall that we have algebra square, algebra, number equals to 0. That will always be the format we want to work with, right? So using this particular format, we will move the 351 over to the left. From here, we will calculate the discriminant. It will turn out to be 28 squared minus 4 times negative 351. Don't forget the negative on the 351. Once you work this out, it will give us 6,400, which is clearly greater than 0, implying that we have 2 distinct real roots. Last but not least, part C will be the same thing again, right? We start by moving the 24x to the left in order to create the format that we have talked about. Algebra square, algebra, number 0. Once you have this, the discriminant will be b squared minus 4ac. This will miraculously work out to be 0, which implies that we will have 1 distinct real root. Right, and that will be all. So now that we are through with the basic discriminant stuff, let's take a look at something marginally more interesting. Take a look at question 9. Question 9 tells us that we have a line and then we have some weird graph. They didn't say it was a quadratic, it's just a weird graph that has x squared, correct? And they want us to find the smallest possible integer value p can take. Smallest possible. So if it is smallest possible, that means that we're not actually looking for a range of values. We're only interested in one particular answer. So keep that in mind as we work this question out. So for question 9, I think it is obvious that due to the fact that we have a line and a very weird graph, we will simply be doing things in a graphical method, and that means we will start with simultaneous equations again. So we have y equals to 2x plus 3, which is already suitable for substitution. So let us sub this guy into the graph of x squared plus xy equal to p. This will give us x squared plus x times y, which has now been replaced, equals to p. From here, we will rearrange this, and let's see, you should get 3x squared plus 3x minus p equal to 0. Now, because the question told us that we have an intersection, right? It cuts at two different points. In other words, we have two distinct, which, if you recall, is essentially the same as saying two distinct real roots, because one real root means one solution means one intersection. Therefore, two intersection means two real roots, two distinct real roots. And this implies that the discriminant of the quadratic will be greater than 0. So over here, the discriminant will simply be b squared minus 4ac, don't forget the negative on the p, he will be greater than 0. This gives us 9 plus 12p greater than 0. From here, p, or rather 12p will be greater than negative 9, p will be greater than negative 3 over 4. And therefore, the smallest possible p that is an integer will simply be 0. Don't forget to answer the question. The answer is not, oh, p is greater than 3 over 4. Yes, that's correct, but what is the question asking for? They're asking for the integer value that is smallest possible. They're looking for one number. So we will start from negative 3 over 4, and we will look for the numbers greater than. So what's greater than negative 3 over 4? And it's an integer. We have 0, 1, 2, 3, blah, blah, blah. And from there, then we will say that the smallest one is 0. And that is the real final answer. Alright? Now this applies for all math problems in general, especially in A math. Being a student and taking an exam paper is honestly a bit like customer service. Customer is always right, and you always want to give the customer what they ask for. So if they ask for the smallest integer, then we will do exactly that. Nothing more, nothing less. Alright, now the next problem over here, question 10, tells us that we have a random line x plus y equal to 14. It cuts another curve, right? Y equals to q plus 8 over x. Q is unknown. Again, notice this is not a quadratic. This is just some random ass graph. Could be anything, really. So, okay, for those of you who already know, however, this is actually a rectangular hyperbola, right? So we should expect to see something like that. And afterwards, we have some line of some sort, maybe over here, for example. Maybe over there, you don't know. So, in any case, even if you don't know how the graph works, it's fine, because they have told us that the line and the curve meet each other. That means that there was at least one cut taking place, which means that we can have discriminant equal to 0 or discriminant greater than 0. Naturally, let us just combine these criteria and say that the discriminant is greater than or equal to 0. So over here, do take note as well. This time around, they're asking for the range of values. Alright, customer service. Answer to what they want. Give them what they want. So over here, we have y equals to q plus 8 over x. I will substitute this guy into the line, which is x plus y equal to 14. From here, let us multiply everything by x, which will give us x squared plus q plus 8 equals to 14x. From here, we will rearrange, and it will give us x squared minus 14x plus q plus 8 equal to 0. At this point in time, I'm going to compartmentalize q and 8 together in a single bracket because both of them are in the same family. They don't have any algebra, right? So from here, then I will say that the discriminant, which is equal to b square minus 4ac, the c will be all of the numbers without algebra. So it's not just q, it's q plus 8. That's why I put the bracket there, right? So b squared minus 4ac, this will be the discriminant. He will be greater than or equal to 0. All right, so let us open up these brackets. You're going to get 164 minus 4q greater than or equal to 0. And this implies that negative 4q is greater than or equal to negative 164. Therefore, we will divide both sides by negative 4 and get q lesser than or equal to 41. And this will be the range of values for q. As a reminder, whenever you are multiplying or dividing by a negative number and it is an inequality, we will have to flip the direction of the inequality. In this case, greater than or equal to gets flipped into lesser than or equal to. Right, so this leaves us with our final problem of the day, and then we will be done. The last problem, question 11, wants us to solve some quadratic inequalities. Notice they're not asking you to prove positive, negative. If they're asking you to prove positive, negative, for example, if it is a proof question, we can simply use completing the square, right? This is what we have covered in our previous lesson. Like so. But in this case, it is not a proof. They are simply asking you to solve the inequality. In other words, find the values of x. So we'll be finding a range of values of x. So if you remember our steps, step 1 is to make sure that we are in the same shape as a quadratic formula. Algebra square, algebra number, 0. In this case, we already have this shape, so actually we've already won. Step 2 will then be to factorize, and in this case, your factorization will give us the following. By the way, for those of you who want to divide by 2 to get rid of the extra numbers, you can do that, but please make sure you make that a separate step from the factorization. Don't just factorize immediately and then divide by 2 in the same step, because as the teacher, I will see 2x squared, and then I will see it changes into x squared, and then I will get confused. So don't do that. Separate the steps if you want to divide the numbers. In this case, you can divide everything by 2. I'm lazy because I'm a math teacher, so I'm not going to do that. I will simply factorize immediately, and from here, we will move on to the third step. Step 1, change the shape. Step 2, factorize. Step 3, do a lousy drawing of the graph. In this case, we have a U-shaped graph. From the bracket, we can recognize that the solutions, or more strictly speaking, the x-intercepts will be negative 13 and negative 1. Now, in this case, positive is on top, negative is below. In this case, the question wants us to find less than or equal to 0. So I'm going to be below over here, which means I'm going to be in between. And this will be my answer. So the number line diagram will look like this. In this case, it is not a strict inequality. Make sure to shade the dots. Alright? Now parts B and C will be the same. So we have this guy. Once again, you notice he is already in the perfect shape. X squared, x number, 0. So step 1 is already done for us. Step 2 will be to factorize. The factorization will be as follows. As a reminder, based on what I said in the previous lesson, there's no need for you to actually do the factorization manually, right, with this method. If you would like to simply use your scientific calculator, that's perfectly fine. Recommended, actually. So from here, step 2, factorize. Step 3, draw a lousy diagram of the graph. In this case, we should cut at positive 5 over 7 and at negative 3. The question wants us to be greater than 0, so we're going to be on top, which will be these two separate boundaries. I will be to the left of negative 3 or to the right of 5 over 7. And therefore, x is either less than negative 3 or greater than 5 over 7. Don't forget to use the English word or, not the English word and. There afterwards, we will draw the diagram for them. In this case, it is a strict inequality, so we will have to use the hollow dot, right? So these will be the drawings. Okay. Now, if we're alright with this, then we have the last exercise for the day. Last exercise for the day is actually not starting off in the quadratic form, but that is no problem for us. We are used to quadratics. The previous lesson was, or rather the previous video was 1 hour, 30 minutes? So that was a lot of exposure already. This is why I spent so much time on the previous lesson. So over here, we have 2x squared plus 9x less than 56, right? And we will simply start off by changing it into algebra square, algebra number 0. From here, then we will then be able to factorize it into 2x minus 7, x plus 8 lesser than 0. Right, so that's step 2. Then step 3 is to draw your lousy diagram. In this case, we have a U-shaped graph again. It's going to cut at negative 8 and cut at positive 7 over 2. And in this case, the question says less than 0. So we have the top, which is positive, the bottom, which is negative. They say less than 0, I'm going to be over here. I'll be in between the two magic numbers, and therefore, x is greater than negative 8, but at the same time lesser than 7 over 2. And from here, we can draw our diagram. Again, we will be using the hollow dot because it is a strict inequality. So this will be your diagram. Right? And that concludes our little crash course on this topic. After we are done with this, the next thing we'll move on to is we're going to talk more about quadratics again, but this time instead of quadratics by themselves, we're going to look in the opposite direction and look at the mathematics of square roots. Alright, if you have nothing else for me, I have nothing else for you. You're dismissed. Since the stream isn't over yet, I would like to spend just a minute or two briefly talking a little bit about set notation. Now, when we are given specific ranges of values, for example, let's say x is between -3 and 5 exclusive, some questions might want you to express this range of values as a set of numbers instead of being a range. So there's a few ways we can do it. The simplest way for most students, those of you who are watching, by the way, who are from my class, if you are not a Sec 4 student, you probably don't need to care about this. For those of you who are Sec 4 students, typically the approach we will use is to simply go set builder notation. We will say x is a real number such that x is between -3 and 5 exclusive. So this is option number 1. Option number 2, right, is to simply use interval notation. For example, we can say something like that. There are other options as well, depending on what exactly the question is looking for. But typically at your level, set builder notation and interval notation suffices. I honestly recommend set builder notation because not all schools will talk about interval notation at your age, especially since most of you are 14, 15, 16. So we will not be so hasty about things. Right? As another example, let's say I have -1 lesser than or equal to x lesser than or equal to 10. Option 1, we will say that x is a real number in between -1 and 10 inclusive. Option 2 is interval notation, -1 to +10 inclusive. Right? And as a third example, let's say we have, oh hey, that's the next lesson stuff. Nice. Let's say we have, for example, 2 to x to 11. X is an odd integer. Then of course your option 1 will be x is an integer such that I am between 2 and 11, with 11 inclusive, 2 exclusive. Option 2, if you want to use intervals here, it will be a bit silly. Then we will say that I am not including 2, I am including 11, and I am including the additional restriction that we will be an integer. Right? And if you have ranges that are split apart, right, the language of math and English can still be reasonably combined together. For example, if I have x lesser than -2 or x greater than 3, then option 1, set builder notation, will simply be x is a real number such that x is lesser than -2 or x is greater than 3. Right? We are just copying, honestly. Option 2, which is interval notation, this will be unfortunately uglier. If x is lesser than -2, then he can be starting from -infinity, exclusive, to -2, like that. Or, so we will use union, right? Or, he can start from 3 and go all the way to infinity. This is fine as well. So as another example, let's say x is lesser than or equal to 3, or x is odd integer greater than 4. Then in that case, step 1 will say that we will say that x is a real number such that x is lesser than or equal to 3, or x is an integer such that x is greater than 4 and is odd. For example, you can use normal English if you want, so this is perfectly fine as well. So if you want to rearrange it, for example, you want to say or x is an odd integer such that x is greater than 4, that's fine. The English is not so big of a deal. And then of course, if you want to use intervals, then it's going to be very ugly. We can say this for x lesser than or equal to 3. And then if you have integer greater than 4, then we will union with x being an odd integer greater than 4. So we have this intersect with integer. Right? So this is perfectly fine as well, although it's a bit ugly. Of course, these are very fringe scenarios. I do not expect to see these in the examinations either. Yeah, so chat is asking about using round brackets for infinity. The reason why we use round brackets is the same reason why we normally don't write something like this. At least we formally don't do so. Reason is because infinity is less of a number and more of a concept. It's just like saying x equals to apples. It can make sense, but in a world that's supposed to have only numbers, then it makes a little less sense, right? Because then what is apples? Is it ap squared L multiplied by the Euler constant? What's going on, right? So because of that, we normally like to avoid using the equal sign for infinity and negative infinity. That's why we will never write something like this either. We will typically just write this. And then for my Sec 4 students, you can think about why this statement is correct. Alright. Okay, I will be ending this stream now, and then for live viewers, I will be coming back in approximately 1.5 hours. We will move on to the topic on square roots, on surds, and then we will talk about math problems that have square roots on them, and we will also talk about how to find a closed form exact representation of nested surds. We will also introduce a simplified version of the conjugate root theorem for real numbers and rational coefficients of quadratic polynomials. Right? Thanks for watching, everyone, and I will see you in the next particular crash course lesson.